1 gigabyte to gigabyte. With a different sound. It cannot be 1. Anyway, so that was the reason. The register file that you are going to design would be 64 registers, each 32 bits. Why 32 bits? Because the memory bit is 32 bits.
Yeah.
And when you want
There's
to
no 64
bring
bits.
the data from memory to the register, you need to have
So yeah, that's the standard. 32 is the standard.
Right? And your ALU works on 32 bit operand. If your ALU is 64, then you will need 64 bits. Okay? What is this function? So this is something that tells ALU what to act on. This function. Any questions? So this is an example. If you say that this command is register type, the first source is 1, the second is S2, the destination is S3, and the second source is S3. Do you remember this slide? So the command that you want to load into your memory will be like this. Either binary, 32 bits, or 8 nibbles hexadecimal. Okay? So you have to create a file which contains either all binary or unlike this hexadecimal. Correct? These are the options that your ALU should support. For this bit, ignore this part. If you want to implement, that's fine. But for this bit, you don't use this. Okay? All we need is the arithmetic and load and store. Is there anything that we need from ALU for load and store? Yes. Sometimes we need to calculate the address, the effective address, the memory, right? But is there any specific operation that we need to do inside ALU for that? It's just add, right? So there is no new command here. But is that all the commands that we need from ALU to for us? Or do you remember something else as well? Do you remember any other command that we need from yours? No? These are all the commands. If you want to find this, go to appendix A from reference book, and you will find it. This is how you want to interpret the command. So the opcode is 0, so it comes here, looks for the function. If the function is 0, it means that it should left. If it's if you want to look for add, multiply is 24, 18 in height. For immediate command, we don't have a function, so opcode will specify the function, the operation type. I can, so this is the reference clause. If you go to the website, I put the complete reference for the lips command, lips 2000 command. This command take a look at that. But for these labs, all you have to implement are these. Okay, arithmetic. If you want to add on top of that, you're welcome to use. Makes it easier for you to move on to the next lab.
Wait, in the video. The arithmetic go up to or down to norm? Or
Down to the norm? What do you mean?
so all the commands down to norm.
Okay.
Yeah.
Yep. For this week, down to norm. So for branches, we have to say this condition satisfies. In that case, you have to set it to make the PC value again increment. So what are the steps for Lisp computer to operate? To run a command. The first step is to fetch an instruction. We need an instruction, right? To act upon. So first is to read an instruction, which is called fetch. Where is this instruction come from? Very real. The program. Where is the program? Right on your laptop. Where is the program? Physically is inside your disk. Then somebody has to bring it into RAM, which is main memory, right? What else? Is that ready to be run? Where is RAM? You have processor and you have RAM. RAM is outside the processor, so it's not inside. So does it make sense for the processor to go and fetch the instruction from RAM one by one? What happens? Yeah, you have to read a chunk of instructions and bring it inside the processor, store it inside the cache. How many levels of cache do you have?
I think it's 3, right?
Usually we have 2 or 3. Depends on the processor. 3 can be on the main board or inside the processor. You consider 2 levels. After you bring the instructions into the second level of cache, then you have to bring a portion of that inside the first level, right? L1 cache. And from that, processor can execute one by one. Alright? Here, I don't want you to implement cache. If you want, that's fine. But we will consider a small SRAM, static RAM, which acts like a cache point. So, where from the memory we should read the instructions? How do you know which instruction to run? Which instruction? You have a program counter, right? Which you increment. Whenever you run an instruction, you increment it. Or you update it to the next instruction that you think is correct to run. Right? So it can be an exception instruction, or it can be a branch instruction, or it can be the next instruction. Correct? These are all reviews from 112. Right? The assumption here is that you all know. Now don't laugh. Otherwise, you'll be in trouble. You have to go and do it. So now we have the instruction. What should we do? We have to know what's the instruction. We have to decode it. So how do we decode it? You slice it. some part will go to, some part of the instruction is for the register part, right? But what about the others? How do you know if the ALU should be operating in the command or not? Who looks at the function? You have to have a separate logic called as control unit, which equals the rest of the function, right? Other than it's like okay. And after that, ALU should execute your command, right? And if it's a load or store, you have to activate the memory. Either you write to memory or read from memory. Or if it's not a load and store, you have to store the results of operation into the there. Where does the output of ALU go? Register, right? If it's not a load and store, it goes to register. Even if it's load, it goes to register. How long does it take for an instruction to run? For single cycle, all of these are happening in one clock. Right? So how big is that clock cycle? What is the critical line? Now the question comes, what is the critical line? Longest time from where to where?
Use it like that. There's more angle in
From
this.
the moment you fetch the instruction until you write it back. Right? The instruction. So each of these, which command is the takes the longest time to run? Which one? Seems like you already know. So give me the intermark, okay? After you synthesize your processor, you have to mention how long does it take them to reach. So remember this. So the data file. Program counter, instruction memory, register file, and age. This instruction memory here acts like a cache, but it's not a cache. So in fetch, PC